Hey, hello. In this video, I want to talk about how to create mesh terrain models from contour lines or point clouds. And I'm not talking about the patch function. The patch function is very good for smaller topographies, smaller areas. When it comes to large data sets and point clouds and terrain models with contour lines, then you want to stick with mesh modeling and you want to stick as close as possible to the source data, which is the points in the point cloud or the contour lines. There's a very useful tool within the plugin Lens Design, which is a plugin specifically for landscape architects that creates these types of terrains very quickly. But if you don't have that, you can use Rhino, and what I want to show is how you can use Grasshopper to basically build the same model. Let's jump in. All right, imagine you have something like this. This is about, let's check. Yeah, it's a model. It's more than 1 kilometer long. It's part of a mountain range. So imagine that these contour lines would move upwards. They would continue upwards. And it's basically a valley, and then you have a river here. And it's placed into the right elevation. It's 1,332 meters above sea level. You can see in the plan. So there's a river. There's a bridge here, I think, and there's a few buildings. It's a small village in the Alps. Now, if you would like to build now, if you would take these contour lines and you would like to build a terrain model out of this, how would you approach it? So you could take this and try to patch. Of course, that will not work very well. It will approximate pretty much everything, and all these little details here you will not get with patch function. What else could you do? I mean, that's pretty much it. With the mesh tools, you could try to use this mesh from surface, a polysurface, mesh patch. That probably also doesn't work. Mesh from points or mesh from lines. Mesh from lines. I think that could be the one. No, wait. That doesn't really work. Okay. But there is an option called mesh from points. So you could extract the points from these lines first. So you could extract all the points and then take the points and use this function here, mesh from points. And that actually creates an interesting mesh. It's not really exactly what I was looking for. And you have huge amounts of points now. It's not very clean. There's a lot of problems here. So let's not do this. Also remove the points again. It takes quite a while to extract the points. Now, Lens Design has this tool. It's called Terrain, and this is a really good tool because you can add and remove contour lines. You can modify the terrain again. I will just use this terrain and you will see what it does. So I will select this again and just press here, and I can go here and it built a terrain, and that's now much better. So if I go here into render, you can see that this worked quite well. Let me change yes, let's do this. I'm not happy with this color. This color is a bit weird. Dirt, I'm not sure. Yeah, like that. So that has now all the details, and it moves along. And you can see the triangulation. It touches all the points of the curve. That's pretty good. Now, what if you don't have Lens Design? Well, I'll show you how you can build a script which does exactly that. So I'm gonna delete this. Well, let's keep it so we can compare it later, but I will hide it. So let's start from here again. I have my contour lines and I go into Grasshopper. This is the script. It's a very simple script. I can, okay, there's actually already in here. I clear all the values. Okay. So there are two ways to do this. If you have contour lines, which are, because these are polylines, so these lines are actually, they have straight sections. They have just straight sections between the points. So there's a difference between a NURBS curve and these polylines. They're different. But we will look at both options. So we have two options on how we can deal with this. So the first one is, if I have polylines, then you can first we bring in the curves. Grab this here. Oh yeah, I put the bifocals so you can read. Also the name. Okay, set multiple curves. I'm gonna grab everything, enter, and now they're all selected. Now the next step would be to extract the curve points. Sorry, the control points of these curves. You can do this by looking into curve and then control points. That gives you this, and then you're already ready to go to build your surface. You can do this with mesh. You can use this tool, delaunay. You know, it's funny, whenever then I create a video, I actually don't know how to pronounce that. Under mesh, you can find this one, the Delaunay mesh. Delaunay mesh. Delaunay mesh. I think I pronounced it correctly, hopefully. You put this in here, boom, already done. Now it seems like there's a bit of a problem. What was that? Oh yeah, yes. So what I need to do, this was not good, but I need to here simplify it. Simplify. Oh no, not simplify, sorry, flatten. I need to flatten it. And the reason is, why do I need to flatten it? Is because these curves are not, or these polylines are not always, they don't continue. Sometimes they just stop and then continue in another polyline. So that's why it creates a bit of an error when I just use this as it is without flatten it. So I need to flatten this first, and then I'm ready to go. And you see that it's exactly the same model as Lens Design has built it before. So I can bake it, and yeah, it's exactly the same model. It's either terrain, this is the one from Lens Design, and this is the mesh. It's exactly the same. So that's the method they use in order to build the terrain. Now, the other way, so I show you a third way to do. This is a bit more elaborate, but it's useful if your contour lines are not polylines and you need to decide where the points are, where your control points are. You can still use the control points, of course, but sometimes you want to be able to control the resolution of your outputted mesh. And just hide this again. I go back into Grasshopper. Now the other way is I can just still use these contour lines. If I want to place now, let's say I have NURB curves and their control points are pretty spread out and different in each curve. So for example, one curve has control points every 10 meters and the other one every 2 meters and the other one every 5 meters. That's a problem because the mesh won't be very even or balanced. So how could I work around this? I have a curve. I can use divide curve. And by the way, I would not use divide length. I would use divide curve, and I will explain why. So if I would use, so as you can see here, it divides the curve quite randomly. Also close this here. You know, sometimes the distance is fairly close together. Other times it's quite far from each other. And I could change that by changing the count, but then it will also increase it here and so on. You could use control divide by distance or by length. They're very similar, but distance is basically the distance between the points. Length is the curve length between the points. So this is the difference. So I could use this now, and then I can specify length, for example 2, or let's go a bit higher, 7 meters. That looks a bit better, but still I get some areas where I have many points, and others I have not a lot of points. I can increase that, and that means then suddenly I have way more points here. If I go lower, that actually works pretty good. But what it also does, it doesn't always end on the end point, because it uses a specific length, and it doesn't. Here it works actually. Yeah, you probably can use this without any problem. So you could use the length. The other way is to make sure is to actually measure the length of the curve. So I could say length. So it measures every curve, and then I could divide that length. Take this here, and then I can add a slider. Don't know what I have here. Oh no, sorry. So if I divide this by, let's say, I want to create a point every 2 meters, let's say. So then I put this in here, then I get a number, I get a float number. So I would round this, so we don't have a float number anymore. Put this in here, and that gives me rounded numbers, integers. That's what I want. Now with that, I can go into curves, divide curves, and I use this number as a count. And probably I would use the floor. This is always the lower. It's rounded to the lower number. Count, and I put it here, and that gives me a very even distribution of points per contour line. And with this, I can use the same tool, and that creates an evenly great mesh. It's just not as exact as this method. So you can see here points are actually offset from these original kinks, but it's quite valid as well, and you can also then play with the resolution of that mesh. All right, I think that's it. Just want to check if I can smooth the mesh somehow. Yeah, smooth mesh also works, but that then goes actually very close to the patch function. Nevertheless, you will never be able to create a detailed terrain model like this with the patch function. All right, that's it. See you in the next video. Ciao.